Okay, minasan, konnichiwa, Zamurai Engineer desu. So in this video, let's start our course, which is principles of reinforced concrete and pre-stressed concrete. Anyway, this is again a new subject. It is not the same with previous engineering subject because we are now on the new curriculum. So I would like to explain our course is actually described. Okay, our course is described by this document. Again, this is what? This is the rules and regulation, or the policies and the standards of Bachelor of Science in Civil Engineering. And we have to follow the CHED CMO 92 series of 2017. Principles of reinforced pre-stressed concrete. Beforehand, we have a subject reinforced concrete design, and at the same time we have another subject, pre-stressed concrete design. So in our school, we only have reinforced concrete design, or RCD. So that's why before it is called RC, meaning reinforced concrete. RCD meaning reinforced concrete design. And PC meaning pre-stressed concrete. PCD, pre-stressed concrete design. That's why it's harder as of now because it is called principles of reinforced pre-stressed concrete. And now we can shorten it up to what? PRPC. Okay, PRPC. So it is just the same as RCPC, but we are going to call it in short PR, meaning principle of reinforced, PC, pre-stressed concrete. So PRPC. Again, this is a course that will provide you with the fundamental concepts and principles and theories in structural strength analysis and design of what? There are three members: plain, reinforced, and pre-stressed. Okay? So meaning to say, this is a new subject, but because of the word principles, okay? Previously, it is called reinforced concrete design. So all about reinforced concrete design. But now, it is only dealing with principle to provide you with fundamental concept, principle, and theories. Okay? So meaning to say, the discussion would be lighter, no? Light. It's not stronger, not heavy on details. No? So meaning to say, on the disadvantage, you will not appreciate the subject, and you will not, therefore, consequently, will not feel the subject as an important tool to be a civil engineer. It's not yet, no, because it was only about principle. What about the practice? What about the problem solving? What about the design? We will again contribute to that, but only lightly, only short summary, only short discussion of that. because it says here that it is only what? Providing you with fundamentals. Okay? Fundamentals. Okay? So the advantage of this is that since this is fundamentals, nothing difficult would happen. Nothing short of difficulty, nothing short of problematic would happen in terms of what? Passing this course. Okay? That is the advantage of this. Okay. Anyway, this is a CHED rules and regulation. That's why we have to follow, and this is the reason why we have K to 12. We have 4 years engineering course, and the design of the 4-year engineering course is actually for civil engineering alone. They distributed the heavy subject, meaning more on details, focused on practice, focused on being an engineer, focused on the activities a real civil engineer will do, okay, on their job. Okay. So in this course, it is not yet like that, no? We will just give you an idea. That is what we meant by fundamental. We'll just give you an idea here. But because this 4-year course also has distributed, again, I said, distributed the major tracks, major specialization into what? 6 different specialties, namely construction, engineering, environmental and energy, transportation engineering, geotechnical engineering, hydraulics and water resources engineering, and what is the other one? The last one. Transportation, structural engineering. So this means that the heavy subjects are on those specialization subjects. So you will have a specialization subject that would become an elective, sort of an elective. That is actually not an elective, but instead it is a specialization subject. In our university, I propose 2 specialty to be offered, that is transportation engineering and structural engineering. Therefore, those of you who would like to choose structural engineering will get those heavy subjects leading to structural design. Okay? And those of you who would like to choose transportation engineering would lead you to study more details on transportation engineering. Okay? So those are the 2 specialties offered by our school. So that's my proposal. No? So I think they accepted, and we have that in our school. So what about if you would like other specialty? We cannot give you that because we have limited number of students, and therefore we cannot offer all of the specialty. Unlike in our other school, there are other school like the #1 engineering school in the country, which has 22 different engineering degrees to choose from. You can select different engineering degrees, 22. Plus all of the 6 specialty of civil engineering. So it is about what? 22 plus 5 and therefore 27. They have 27 engineering degrees to choose from. Okay? So in our school, we have only 3 engineering. Okay? So therefore, you have to limit your choices into either you will go to structural engineering and the others would maybe choose transportation engineering. So what is transport engineering? We are not going to study vehicles. We are going to study those civil works that would give infrastructure to those vehicles. Okay? What are the infrastructure to vehicles? Roads, highways, bridges, okay? Flyovers, skyway, airport runways, okay? Port, docks, okay? Docking of ship, okay? So therefore, we are related to those transport vehicles, we are related to airplanes in such a way that we will provide as a civil engineer those facilities, those infrastructure that would be used by those vehicle. Okay? So those vehicles are being studied by mechanical engineering. No? Okay, but we will provide the infrastructure. Okay, so those are the focus of transport engineering specialty under the BS Civil Engineering. What about structural engineering? Structural engineering is the one focused on design. You will feel being a civil engineer because you would be designing buildings, you would be designing towers, you would be designing structures. Okay, so design. Okay, and after designing, meaning you have to compute, you have to check, you have to give a specification, you have to set assumptions for the consumption of what? The construction engineer. So we don't have the construction engineering option in our school, but you can relate to construction engineer, to project engineer, because they are the one who will use your design. Your design would be documented in terms of design analysis and engineering plans. Okay, so engineering plans. So what do we mean by engineering plans? So I have plenty of engineering plans here. So these are what we call engineering plans. Okay. So these are the engineering plans. Okay. So okay. So this is one of your requirements. You have to provide an engineering plan. You have to provide an engineering plan for yourself, for your own study, and I will check. And later on, you will pass, you will submit it, because some of your computation would be based on that plan. Okay? Okay? So that we will have what? The practice part, because this course not only have the lecture portion but also have laboratory part. 3 hours lecture, 3 hours laboratory part. Unlike in principle of steel design or PSD, we have 2 hours lecture and 3 hours design. So only 5 hours per week. So this course is reinforced pre-stressed concrete design, this is 6 hours per week. Okay. Okay. So that is the difference. So 3 hours of laboratory, meaning I will give you something to do. Okay, something to practice, something to solve, and that means you have to provide. So the assignment for next week, you have to get hold of a copy of an engineering plan. Okay, you have to look for it, you have to search a copy. Okay, an engineering plan that has an approval, no? Unapproved. Okay. You cannot see it. I will, no, I will, yeah. Can you see it? I will stop sharing. I will spotlight my, okay. Can you see this? Okay. So this engineering plan has an approval. Approved. So there is an approval. Okay. So this has an approval. Okay. So the requirement is to get hold of a copy of an engineering plan. Okay. So an engineering plan will always have what? Structural plan. No. The minimum requirement is structural, architectural, electrical, and plumbing. That is the minimum requirement. The full requirement is, in addition to these 4, we have geodetic or the site and zoning. So the title certificate, no? Certificate of title, Torsion certificate of title or TCT by a geodetic engineer. Also, we have what? Sanitary engineer or sanitary plan. We have electronics plan or ECE. Okay, and mechanical. So all in all, there are 8 professionals for a full engineering plan, but a small project would only need 4. 4. So because you will not have a building without architectural plan, you will not have a building without structural plan, you will not have a building without electrical. It is impossible nowadays. Before 30 years ago, 50 years ago, 100 years ago, it is possible to live without electrical. You cannot live without electrical nowadays. You cannot even live without cell phone. Where can you charge your cell phone if you don't have electrical? So it is a necessity. Electrical is a necessity. Okay? And plumbing also a necessity, because where can you go to pee or go to poop? Okay. Okay, flying saucer. Okay. Okay, it's not possible. You need to have what? Toilet and bathroom. CR. You need to have a CR. And also a water system. Okay, so that's why it is necessary to have those minimum requirements. Okay. Okay. Those I am talking to you the reality. The reality. What are they requiring from the what? Engineering, city engineer's office? Okay. Therefore, you have to look for a copy of those plans. So, as an example, therefore, your plan would what? Have at least 4 pages, because the minimum is 4. So at least you have 4 pages. Okay, and average about 6 pages or 5 pages. That is the average. For small, you only need to take hold of a small project because I will let you compute. If you have what? A very big engineering plan, it's okay, but you have to compute it. So it's too much for you to handle, therefore. Or maybe if you have a very big engineering plan, for example, there are times where a student submitted what? 24, about 24 pages of plans. Okay, so I let them what? Divide into several person. They group, no? They solve it in group. Okay, so in that case, that is their what? Practice of what? Problem solving during the laboratory hours. Okay, so I would expect you as an assignment to get hold of that next week, and the deadline, better to have next week, but the deadline next week. Okay, so I will give you even after the election, because I will what? I will focus more of lecture, because how can you practice problem solving if we do not have so much lecture? So I will focus more on lecture. Therefore, I will use some of the laboratory time for lecture, and then later on I will use the lecture hours for laboratory time. Okay, to get even, no? To be balanced, no? So because we are early on to this course, so we will need more lecture first, and then later on more laboratory later. Okay, okay. Baltan, please mute yourself. Baltan.
Sorry, sir.
Okay, let's continue. I am recording this session because I would like those who are not available today, who are absent today, to be able to view this orientation. This is our orientation. Okay, so in our orientation, I will again show you another. Okay, I will show you again back to the CMO 92 2017. So it says here that the prerequisite is structural theory or theory of structure. Okay, so meaning to say you need to have a minimum knowledge. Again, I am reminding you, I am warning you, because this subject we will not teach you, we will not lecture, we will not discuss. We will just use. We will use immediately the concept learned from structural theory. Okay? We don't need to explain them because you already know structural theory. You need to have what? The minimum knowledge of structural theory. Okay? Again, what do we mean by minimum knowledge? You can take a look. You can search for structural theory. Okay? And let us do it now. Let us do it right now. Let us look for the structural theory in this, or theory of structure. Okay. Let's go back. Let us search for it. Okay. So structural theory, computation. So you also have a laboratory for structural theory, and you also have the lecture part. So structural theory. What do you mean by structural theory? Okay. It means that you can identify, okay, as you can see here, and classify various types of planar and spatial structural systems and the manner by which these are supported for stability. Okay? Very clear. You can determine the state of static and kinematic, determinacy, and stability of structural system, externally and internally. Okay? You can apply, meaning you can do it. Okay? You can apply the methods of structural analysis, meaning you can solve, okay, for external and internal actions on various types of structural systems due to static and moving loads. Okay? Okay, so very clear, no? And you can develop intuition on deflected shapes of structures under loading, meaning you have an insight. Okay? You develop an insight because of the learnings that you gain. So what are the details of this? You can take a look at this. Okay? So these are the topics that you learn in structural theory. I am not asking you if your teacher discuss it or he or she lectured on it. I don't care. You have to be prepared to know the minimum knowledge about structural theory. Okay? That is what I am looking for. Okay? For example, you know, classical method of structural analysis, translation or deflection, rotation. You know how to statically to analyze statically indeterminate structures. Okay? DIM method, AMM method, CBM method, Castellanos method, unit load method, partial derivative method, MDM method, three moment method, okay, SDM method, and method of consistent deformation. So, if I am the teacher of this, and before I am teaching this subject, I always see to it that I complete this. Even this one, 5. Part 5, what are those? Portal method, cantilever method, factor method. Okay? We go as far as influence lines. Okay? You have to be able to know what do we mean by influence lines. External reaction, internal stress resultant of indeterminate. So those are the minimum requirements. Okay? Okay? So let's go back to our subject. So our course is reinforced. Okay, this is our course. Principles of reinforced prestressed concrete. Okay. So in short, PRPC. Okay. So we will have what, 6 parts or actually 7. I think it is 7 parts. So part 1, properties of concrete, we will discuss. In part 2, analysis for flexural strength. In part 3, we will discuss design for flexural strength. Part 4, analysis and design for shear. Part 5, analysis and design for torsion. So immediately we will discuss about analysis in design. We will not discuss what is shear. We will not discuss what is torsion. So those things are already known from theory of structure or structural theory. Okay? Okay? We will immediately use what you learned from shear, from torsion, from bending, from flexure, okay? And immediately use those concepts and principles into what? Analysis and design of members of the elements that we need in our course, okay? Compression members, okay? What do you mean by that? Okay, and number 6, that is design and analysis for compression members, and number 7, prestressed concrete. We will give an example, and later on, it will be very clear to you what do we mean by analysis and design. Okay, there is an specific description of what is an analysis and specific what is a design. When we are talking of structural design, this is a structural design about what? Reinforced concrete and prestressed concrete. So last part is about prestressed concrete, all in all. Okay, so these are the coverage of the topic that we have to learn. Again, we will use any authors, but if you would like to ask me, I will what? I will use, for example, 3 different authors, which is also suggested by the civil engineering CMO. I may use White, McGregor as an author. I will. I could also use McCormack. Okay, so McCormack is also good. So this is the White, McGregor. As you can see, the names are there. Okay, so reinforced concrete. Okay, reinforced concrete by White and McGregor, meaning James White, James McGregor. They are both of the same name, no? James. Okay. Also, but you only need to use one. You have to pick one. Any author will do. I am suggesting either one of those author. But if you don't have and you have another author, it's okay. The same concept, the same principle will be discussed. What I'm talking about is these topics are true all over the world, around the world. It is not true only in our school. It's not true only in our country. It is true around the world. Okay, so any author will do, but it depends upon the author. There are authors who can explain better than the others, and there are authors who explain so easily than the others. Okay, okay, and there are authors who provide more examples, and there are authors who provide more discussion. So it depends. So that's why we pick